Only water. Oh, I gave you the wrong answer. Well, I almost gave you the wrong data. No, it isn't only water. The colorless isn't only water. All right. Does the colorless contain any blank? Yes. All right, now I'm going to see who's been listening. I'm going to call on somebody. Don't anybody say anything. I'm going to call on somebody that hasn't had their hand up yet today. But I'm going to give you the clue. Something that's in the colorless. It's a substance that the ancient camel caravans traveled across the Asian deserts to obtain because they didn't have it and they wanted it. What is it? What is it, Kendall?
Salt.
Okay. I wanted to see if Kendall was listening. Salt. All right, 17. Does the colorless contain blank, 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 salt and water? Raise your hand if you're somebody I haven't called on yet today, and you know what four-letter word goes in the blank. Somebody I haven't called on yet.
Jacob.
I've called on Jacob. I haven't called on you. Only.
You are smart.
Yes. Okay. All right, let's review. Raise your hand if you can tell me everything that's in the red. Everything that's in the red. Let's have somebody that hasn't participated yet tell me everything that's in the red. Jackie, everything that's in the red.
Water.
Water. Raise your hand if you can tell me everything that's in the green. Shayla.
Salt.
Salt and water. Okay. Raise your hand if you can tell me everything that's in the colorless. Nathan.
Water and salt.
Water and salt. Okay, now based on the data that you've gathered so far, somebody should be able to tell me why the red is less dense than the colorless. Who knows why the red is less dense than the colorless? Jessica?
Because green contains salt and red doesn't.
Okay. Pure water is less dense than salt water. That's why the red rises. That's why the red is less dense. All right, raise your hand if you can tell me why the green is more dense than the colorless. Why is the green more dense than the colorless, Emily?
Because it also contains salt.
Well, now wait a minute. If we ignore the food coloring, the colorless and the green both contain only water and salt. The green and the colorless contain only water and salt, but the green is more dense. Who can figure out how the green could be more dense if they both contain only water and salt? Jeremy?
Because the green, it has green food coloring in it. And
But we found out that the food coloring didn't make any difference. How could that be, Darby? You had your hand up. How could the green be more dense if they both contain water and
If
salt?
the green has more salt than the colorless liquid,
18. Does the green contain more salt than the colorless does? I'm going to have you vote. Here's the question you're going to vote on. Does the green contain more salt than the colorless does? How many say yes? How many say no? Well, what tells you that the green must have more salt? What tells you that the green must have more salt, Jake asked?
because you can see it has more density because it goes down.
Well, because it's more dense. All right. Yeah, because it's more dense. Okay. Well, I think we have all the data we need. So it's time to write a good conclusion, a complete conclusion. This is still reliable and valid, but I'm going to continue it up here. Now, because the red is less dense than the colorless, but the green is more dense than the colorless. All right. Raise your hand if you can suggest a word that should be in the conclusion that's not there yet. One word. There's several of them. One word that should be in the conclusion that's not there yet. Tanner?
Salt.
Salt. Okay, who can name another one? Another one. Chase? Well, that's not a very scientific word. That's like a, an, and the. Well, not very scientific. Okay. but you're not wrong. Okay. What? Donald?
Water.
Water. Oh, is water in? Oh yeah, water is not in there yet. Okay. What else? Is there any other word that ought to be in that's not there? Well, I'll try to word it so we get those in. Because the red is less dense than the colorless, but the green is more dense than the colorless. Although, this will be final now, so it's okay to copy it. Although, all three liquids contain water, comma, because there's a pause, the green and colorless also contain salt. Period. However, now we have to write a sentence that explains why the green sinks, why the green is more dense. However, what are we going to say? That'll explain why the green is more dense. Jackie?
As a result.
The green contains more salt. All right. This is all you have to have on your record sheet today, right there. Copy that down. I'm going to start putting my focus away, but then I'm going to tell you a story about where this happens in nature. This is density layering. This is density layering. See, layering that occurs because of different densities. Okay, I'm going to tell you where density layering occurs in nature.
I dare somebody drink that. Mix it up.
Okay, now I'm gonna move this because I'm gonna make a diagram on the board, and I want the diagram to be visible to the camera. I'm gonna draw something, and I want you to tell me as soon as you know what I'm drawing. See if you recognize what I'm drawing. Okay, I'm gonna erase this. If you don't have it, get it from somebody else, because I want to draw the diagram there. Tell me as soon as you know what I'm drawing. All right.
Hey, somebody's here. See it. I'm here again. What is it? A toothpaste. Hey. A broken cavity toothpaste. Are you sure? Mountains. A rhinoceros.
You
Coast? The inside of an ear. Washington.
Who said Washington first?
Emily.
About 3 people. That's a map of
That does
Washington.
not look like Washington.
Okay, here's the Olympic Peninsula, where Port Angeles and Forks are. Olympic Peninsula. Here's the Kitsap Peninsula. You don't have to draw this.
Okay, good.
That's where Bremerton and Paulsbo are. Okay, up here, here's Hood Canal. Hood Canal, named after Captain Hood, an early explorer. Here's Puget Sound, named after Captain Puget, an early explorer. There's an island up here, a big island that's part of Canada. Who knows what the name of the island is? Wyatt? Well, Victoria is on the island. What's the island called?
Vancouver.
Vancouver Island. Who's Vancouver Island named after? Captain Vancouver, an early explorer.
awesome.
Okay, now, I'm gonna have you vote on what the ocean is out here. You're gonna vote. Raise your hand if you think that's the Atlantic Ocean. Raise your hand if you think that's the Indian Ocean. Raise your hand if you think that's the Pacific Ocean. Well, I'm glad to see you know your geography. Okay. All right. Raise your hand if you know what state this is down here. Raise your hand. What, Jake?
Me?
This, yeah, Oregon. Okay, that's Oregon. Okay, raise your hand if you know what state this is over here. Wyatt? Idaho. Raise your hand if you know what country this is up here. What country, Stevie? Canada. All right. Now, here's Olympia, our state capital. Here's Tacoma. Here's Seattle. Here's Bellingham. Okay, I think we've got everything like, oh, what's this river right here called? Columbia River. Columbia River. Columbia River. Okay, and the Columbia River forms part of the state boundary, and then it continues on up like this. Okay, now that's just a drawing. I haven't begun to tell you the story yet. All right. Every year I go fishing out here in a fishing village called Sekiu, S-E-K-I-U. In Klallam native language, that means calm waters. There's a bay there where the ships can come in to get out of the storms. Sekiu. Okay. I used to fish there 80 days a year. For about 15 years, I fished there 80 days a year. I'd go out and back every other day and take a different group of 3 friends every time. So I got to visit with all my friends that way, and we caught a lot of salmon. Every day we'd go out here. I kept my boat in the water all summer long. Every morning we'd go out here in the middle, and I would have one person fish with 50 feet of line, another person fish with 100 feet of line, another person fish with 150 feet of line, and another person fish with 200 feet of line. 50, 100, 150, 200. Can anybody guess why we did that right at the start? What were we trying to find out, Jason?
Where the fish are.
How deep the fish were.
Yes.
Okay, the salmon. Now here's something, well, I told you that focus involved density layering by salt content. Out here, there are, right here, there are 3 layers of water. There's a layer on top that's fresh water, and then there's a layer under that that's slightly salty, and then near the bottom there's a layer that's very salty, like that. Okay, now one thing that a lot of fishermen don't know is that every kind of fish has a different salt preference. So you don't find all fish in all layers of the water. This is an unusual layering arrangement. It happens here because the fresh water here comes from rivers that are flowing, Sekiu River, the Hoko River, the Dungeness River flowing out there, and their fresh water tends to go to the top because it's less dense. Okay? The very salty water comes from the Pacific Ocean on the incoming tide. The tide comes in twice a day and goes out twice a day. Well, on the incoming tide, the very salty water comes in here, so that's where that comes from. The medium salty water, or the slightly salty water, comes from Puget Sound. Puget Sound has all these rivers emptying into it. The Nisqually, the Puyallup, the Duwamish, the Skagit, the Stillaguamish, and all those rivers. So they mix, the water from those rivers mixes with the very salty water coming in from the ocean, and it makes it slightly salty. So that's how you get these 3 different layers. This comes out here on low tide, when the tide's going out, and the very salty water comes in when the tide's coming in twice a day. Okay, well, a lot of fishermen don't realize that every kind of fish prefers a certain salt content of water. A fish that prefers very salty water is the halibut. They're a flat fish, like a flounder, and they prefer very salty water, so if you want to catch halibut, you fish near the bottom. A fish that prefers the fresh water is the steelhead. The steelhead is a fish that raises its young, spawns in the rivers, freshwater rivers, but it goes out to sea for part of its life. It prefers the freshwater, so if there are steelhead migrating out here, you'll find them up here. The salmon like the slightly salty salt, so you'll find them down in this layer. Now here's something important to know. Those layers aren't always the same thickness. One day, this fresh water might be a foot thick, and another day it might be 20 feet thick, depending on how much river water is flowing in and what the tides are and so forth. Same way with these layers, they vary in thickness. So, the salmon prefer this layer, but you never know exactly how deep that layer is going to be. So, we fish at those 4 different depths, and where do we decide where to fish? Where do we decide for all of us to fish? How do we decide where all of us are going to fish after about a half hour?
Where, like, the same place, except for, like, how deep it is, whoever got
the most salmon strikes, that's the depth we fish at. See, now, we have really good luck. We usually come back in with the limit, and there'll be people coming in at the same time we are, and they'll say, oh, I fished all day and I never got a strike. And then I'll say, well, what bait did you use? Herring? Well, I use herring too. They used the same bait I did. Why do you think they fished all day and never got a strike? What could be a reason for that, Stevie? They didn't fish at the level where the salmon were. You're not going to catch any salmon down there. Very few anyway. Okay, I invented a saying when I was about your age after I had done quite a bit of fishing. Here's the saying, see if this makes sense to you. If there aren't any fish there, you're not going to catch any. Right? If there aren't any salmon there, you're not going to catch any. Okay, so that's important to know. Now this doesn't happen all over. Out in the middle of the ocean, you don't find these distinct layers like this. But in a place like that, you do find them. So that's something, that's density layering by salt content. There are other ways that density layering can occur, and they'll come with additional focuses that I present to you later on. Okay, that's the end of this focus. The focus today is called the collapsing can. And the problem is, why is B collapsed but A not collapsed? I have these 2 cans, A and B. And A is what you might call a normal can, but B is collapsed. Okay, there's a reason for that, which is related to the manipulated variable. So your task is to find out what the manipulated variable is and how that's related to this can collapse.